In this .NET 6 course, Amikai will teach you how to build a REST API. Amikai is a software engineer at Microsoft, and he is great at breaking down complex technical topics in a way that's easy for beginners to understand.
Hi everyone, today we're going to be building a CRUD-based REST API completely from scratch. I'm really excited to be collaborating with freeCodeCamp on this video, so I really hope you're going to like it and I can't wait to hear what you think. Okay, so what are we building today? Well, today we're going to be building the back end for the fictional application Boober Breakfast. What is this Boober Breakfast application? Well, it's basically a system in which you can create breakfasts. And as you can see, every breakfast has a title, a description, a start and end time, some savory items over here, and also some sweet items. And because what we're building is a CRUD-based REST API, then as you would expect, the actions that we can do are creating a new breakfast, reading breakfasts, updating a breakfast, and also let's imagine that somewhere in our system we have the option to delete a breakfast as well. Okay, so if this sounds intriguing, make sure to watch until the end because by the end of this video, you should have a good understanding of all the topics that we're going to be covering. Okay, moving on to the architecture of the project. So as you can see, by the end of this video, we're going to have two projects. Now you don't need to remember what this looks like, but what I do want you to notice is that we have two projects, one containing the definition of our API. So this models our API definition, and another one with the actual logic of our application. Okay, moving on to the technologies that we're going to use. So we're going to be using .NET 6, and we're going to use the .NET CLI and Visual Studio Code for everything else. As part of this video, then you will get familiar with some new .NET CLI commands and some pretty cool Visual Studio Code extensions, which hopefully you'll be able to take and add to your toolkit. Okay, moving on to the architecture choices. So as we said, we're building a CRUD REST API. This means a system in which you can create, read, update, and delete resources. So not every backend system needs to follow clean architecture and domain-driven design principles, especially when the application is small or medium. It can add a few layers of complexity, which aren't always worth the effort. So today we're going to be building something that is suitable for small to medium-sized applications, and hopefully you'll be able to take what we're going to be building today and use it in your applications, even if yours is completely different. Okay, now even though we're creating a quote simple application, we want to make sure that our application is resilient and it will scale well as our application has more and more features and more error flows. That's why we're going to incorporate some interesting concepts from functional programming and also some principles from domain-driven design, which will make our application more resilient and better organized. Okay, lastly, who am I? So my name is Amikai. I'm a software engineer at Microsoft. I love creating all these visual engineering infographics on the various social media platforms. And I actually just launched a new YouTube channel a few weeks ago in which we write a lot of code. We cover design patterns and architectures that are a bit more advanced than what we're going to be seeing today. So if you like what you see today, then feel free to follow me on the various social media platforms. You might enjoy my content. Hi everyone, Amikai here. I do have a quick disclaimer. So I am a Microsoft employee and these are Microsoft technologies, but I'm not talking on behalf of Microsoft. These are my personal opinions. Okay, so without further ado, let's start writing some code. So as we said, we're going to have two projects. One that models our API and another one which will contain the actual logic of our application. Okay, now if you're asking yourself, why would I want to split my application into two separate projects? Well, having your API definition, which is a bunch of C# classes in a separate project, allows you to define it as a class library and then publish it as a NuGet package. Then if your client is written in .NET, then they can simply consume this NuGet package instead of remodeling the API themselves. Okay, now this also works well with versioning. So as your API evolves and you have new versions, then when you want to publish the V2 of your API, then all you need to do is publish a new NuGet package. And all the client needs to do is simply consume the new package. Okay, so let's get started. The first thing we want to do is create a new solution. So let's go ahead and create our Boober Breakfast solution. So .new SLN, and let's give it the name Boober Breakfast. Okay, as you would expect, this creates the Boober Breakfast folder, which inside has the Boober Breakfast solution. Okay, let's go ahead and create our project. So .NET new, class lib, and let's give it the name Boober Breakfast .contracts. Right, so this is a project that models our API. Great, now let's create our actual web API. So .NET new, web API, and let's give it the name Boober Breakfast. Okay, let's try building the project. So .NET build. And we get a warning that says unable to find a project to restore. Now this may seem a bit weird because we just created 2 projects, but when working with the .NET CLI, then it's not enough to just create the projects, because if we look at the solution file, then we can see it's still empty and there are actually no projects defined in it. So let's go ahead and add both of our projects to the solution file. So .NET SLN add, and we want to add the Boober Breakfast .contracts and the Boober Breakfast project. Click OK. This adds them. Okay, now you can actually do this in a shorter way. So you can do .NET SLN add, and you can specify over here all the projects recursively, like so. So you can go ahead and choose whatever is more convenient for you. Okay, now that we have all of that defined, let's go ahead and open this in Visual Studio Code. Okay, so we open the project in Visual Studio Code. And as we expect, we have here the solution that we created and the 2 projects. If we look at the solution, then after we added the 2 projects, we can see that they're defined over here. If we look at the 2 projects, then over here, this is just a class library. We're using .NET 6, and we have nullable reference types enabled, which basically means if we haven't defined that an object can be null, then it can't be null. Okay, let me just close this stuff over here. Okay, and over here we have the Web API. So because we created the project from the .NET CLI using the Web API template, then we get here a few things out of the box. Okay, so looking at the CS proj. Okay, so as we said, we're using the .NET SDK, .NET 6, and also here we have nullable reference types enabled. Okay, now the first thing I want to do is actually to create here a new folder. It's called docs. And over here, let's create a file, api.markdown. What I'm going to do is paste here the definition of the API that we're going to be building. And I'm going to open it using the Markdown Preview Enhanced extension. If you aren't familiar with Visual Studio Code, then over here you have a tab in which you can search and install extensions for Visual Studio Code. So this extension is called Markdown Preview Enhanced. And all you need to do is select it, click Install, and then over here, when you right click, then you'll have the option to open it using this extension. So let me put it over here so it catches the entire screen. And I want to open it side by side with our client application. Okay, starting with the C of CRUD, then the way you create a breakfast is you basically call the breakfast endpoint using the HTTP verb post. And as you would expect, what you have over here is basically a breakfast, right? So we have the name, which corresponds to this, the description, which corresponds to this, the start and end daytime, which corresponds to this over here. Then we have a list of savior items, which is this, and sweet items, which is this. The only thing that's missing from the schema is perhaps a list of images, but let's imagine that we're just building the MVP, and someone in a future iteration will add this feature as well. Okay, if we created a dinner successfully, then we get the HTTP status code 201 created and the location header, which gives us details on how to fetch the breakfast that we just created if we'd like. And the response content contains all the details that we sent, including a server-generated ID and another server-generated property, a last modified datetime. Moving on to the R of CRUD. So we'd call this endpoint over here and specify the ID of the breakfast that we want to read. And to indicate that we want to retrieve data, then we're going to use HTTP GET. If the breakfast exists, then we'll get HTTP status code 200. And in the response, we'll get the breakfast that we requested. Okay, moving on to update breakfast. Then to update breakfast, you would specify the ID of the breakfast that you want to update and use the HTTP verb put. And in the request content, you would specify the new details. If the dinner was updated successfully, then we get 204 no content. But if the specified ID doesn't exist, then following the RFC specification for put, we'll return 201 created, and the response will be similar to the response of creating a resource. So even though this is called update, this is actually upsert. So we'll update the resource if it already exists, or it'll create a new resource if it doesn't exist. Last but not least, we have the delete breakfast. Basically, you specify the ID of the breakfast that you want to delete with the HTTP verb delete. And if it was deleted successfully, then we'll get 204 no content. So by the end of this video, we'll create an API that behaves in the good flow, like what we saw over here. But don't worry, we're also going to have error handling. So if something goes wrong, we'll return the appropriate response to the client. Okay, so I actually want to open the API definition again on the right, so we have it visible while we're modeling our API. Okay, so let's start with create breakfast. So over here in the contracts project, let's get rid of this auto-generated class. Let's create a new folder called breakfast. And over here, let's create a new file called create breakfast request. And as we defined in our API, so this will be public record create breakfast request. So this will be string name, string description, yes, daytime, start daytime, yes, end daytime. Then we have here a list of savory and a list of sweet items as well. Great, moving on to the response. So actually the response, both of the create breakfast and the get breakfast are identical. So let's just create a single file to model both of these responses. Let's call it a breakfast response. So breakfast response. And actually, let's just copy paste this entire thing. Let's add the extra fields. So this over here will be response. We have here a GUID. And other than these two datetimes, we also have here a last modified datetime. Great. So as we said, we already have this defined over here on the left. Now let's create the upsert request. So upsert breakfast request. And over here as well, just copy paste this entire thing over here. Let's change it from create to upsert. And that's it, right? Great. Now that we have the API modeled in C# classes, let's go ahead and start implementing the actual logic. Okay, now if you aren't familiar with web APIs, and I want you to have something to imagine as we were writing some of the code. So I want you to imagine that when the user clicks the create new breakfast request with a new breakfast that he just defined, then the following details are sent to the server, to the create dinner endpoint. And you can imagine that the request arrives over here at the breakfast controller, and we'll be able to extract the details that were sent and manipulate them the way we want. So in our case, we want to store them in the database. Okay, then in the response, then whatever the breakfast controller returns, then it'll simply be returned to the client, and then the client can take the information that was returned and display it back to the user. So back in our application, because we created the web API using the command line interface template, we get here some files which we don't care about. So let's go ahead and get rid of everything that we aren't going to need. So we can get rid of this weather forecast controller, this weather forecast file, and in the program CS, let's get rid of everything we aren't going to use in this video. So we can get rid of this, of all of this, and of this as well. Okay, now if you're used to seeing both a program CS and a startup CS, then what we have over here is the new template starting from .NET 6, where over here you have the builder variable, which you can use for dependency injection and configuration. And over here you have your app variable, in which you can manage the request pipeline. Okay, now a nice trick that I saw is creating here a scope and putting this inside like this, and same over here. Just makes it seem a bit more organized. Okay, last thing over here, we can now get rid of this package reference since we aren't using it anymore. And that's it. Okay, so let's start defining our endpoints. So over here, let's create our breakfasts controller. So this will be public class breakfasts controller, which will inherit from the controller base. This is coming from this namespace over here. Okay, we want to add the API controller attribute. This is an attribute that we get out of the box with ASP.NET, and it does some heavy lifting for us. Okay, so let's start defining our endpoints. So let's start with a create breakfast request. So HTTP post, and here, let's specify the route. So yes, breakfast. This will be public. iAction result, create breakfast. Let's see what it's suggesting. Yes. And now we can try to add the contract namespace, but it's not recognized. That's because we don't have any reference to the contracts project. So let's go ahead and add this reference. So .NET add, and then we need to tell which project. So in our case, we want the Boo Breakfast project to reference the contracts project. Okay, this added the reference to the contracts project. So now we should be able to add the namespace. Great, and for now, let's just return the request. Next, we have our get endpoint. So let's just copy this entire thing and paste it over here. Let's change this to HTTP get. Over here, let's add the ID. And because we want this to be a GUID, then we can add here GUID, and the framework will enforce that this must be a GUID. Let's change this to get breakfast. And over here, we have our GUID. And for now, let's simply return here the GUID. Next, we have our update breakfast request. So again, let's copy this method over here and paste it. Let's change HTTP post to put. This will be similar to what we have over here. So let's simply copy and paste it. And let's change this to upsert breakfast. And over here, this won't be the create breakfast request, but rather it will be the upsert breakfast request. And of course, we also want to extract the ID from the route. So ID. Okay, and lastly, we have our delete endpoint. So let's copy the get endpoint and paste it down here. Let's change HTTP get to HTTP delete. Let's change the name from get to delete. And that's it for now. Let's close the API definition and make sure that this works as we expect. So .NET build. Created build successfully. Let's go ahead and run the project. So this will be .NET run. And here we need to specify which project. So in our case, it's the Boober Breakfast project. Let's click enter. This will build and run our application. Right now, to make requests, I want to introduce another Visual Studio Code extension. So let's go back to the extensions tab and look over here for REST client. Okay, this is the one. You'll see it has 2 million downloads and a lot of love from the users. Simply click install and you'll be able to run HTTP requests like we're going to demonstrate now. So the way this looks is, let's create here a new folder. Let's copy requests. Inside here, let's create another folder. It's called breakfast. And in here, let's create a create breakfast request. Okay, so it's simply a file that ends with .http. Okay, and the way this extension works, so you basically just write the request that you want to send, and you can see that just writing the HTTP verb already pops out this send request option that you simply click it and it sends the request for you. So let's open our API definition again on the right and create our first request. So we want the host / breakfasts. Underneath, we can define whatever headers that we want. So in our case, we want the content type application JSON, and below our request body, which is this thing over here. Okay, let's try sending the request and making sure that the endpoint simply returns the request as we defined. So we sent it and we got it as we expect. Great. Let's go ahead and create our other requests as well. So over here, we have also the get breakfast request, the upsert breakfast request, and lastly, the delete breakfast request. Okay, let's copy the create request to the upsert request because they're very similar. But instead of post, this will be put, and over here, we'll have the ID of the breakfast that we want to update. So let's just take some ID from over here and paste it in our request. Okay, now something cool that you can do with this extension is create variables. So you can say, for example, that the ID is, let's copy the ID over here and paste it here. And then we can simply replace this entire thing with ID. And you can see that there's even IntelliSense, so you can autocomplete. And over here, you even have navigate to definition. Pretty cool. Okay, so this is our update endpoint. It corresponds to the definition of our API over here. Let's move on to the get breakfast. So let's simply paste this over here. Let's paste the ID as well, actually. And instead of put, this will be get. And the delete will be similar to this, only we'll have here, instead of get, delete. Let's make sure our definition is correct. So create, we already tested. Let's make sure that delete works as well. So right over here, we just simply return the ID. For get also, we return the ID. And for upsert, we should be returning the request. Great, so now that we have everything wired together and we have all our requests defined, let's go back to the controller and think what we want to do over here. So let me just close all these windows on the right. Also, let's stop the application. You can do it by clicking Control-C. Okay, back in our controller, one last thing that I want to do. So because all our endpoints start with the word breakfast, we can simply go over here and write route breakfasts. And then we can remove this, this, and this as well. And because it's very common to have the route simply the name of the class without the word controller, then the framework also allows us to do something like this, where you simply write controller, and then all the endpoints will be prefixed by the name of the class without the word controller. Okay, so now let's think what we want to do. So let's start with the create breakfast endpoint. So as we said, we have here the request. Now we don't want to store the request as it is in the database for a couple of reasons. One, it doesn't have all the properties that we want. So for example, the ID property doesn't exist and the last modified property doesn't exist, but also because we want the flexibility to be able to change things inside our system without having to change the contract that we have with our clients. Okay, so what we want to do over here is take the request that we received, convert it to the internal service model, and inside our application, we'll only speak in the language of these models and not the language of the contracts. Then tomorrow morning, we can create a new API version, and all we need to do is convert the new API definition to our internal service language, and then we can support multiple versions, and our system is more flexible. So for that, let's create our internal breakfast representation. So let's go ahead and create here a new folder. Let's call it models. And in here, let's create our breakfast object. Okay, so this will be public class breakfast. And over here, let's have yes, actually, this seems right. But because we want to make sure that this is always built with valid values, and we don't want to give anyone holding the object the option to simply set new values to our properties, then let's get rid of all the sets over here. And let's create a constructor. Great, let's just wrap the line here so it's visible. Okay, and now not only that no one can change the ID, for example, after it was set, but also over here, we can enforce whatever logic that we want. So if we have some logic, for example, that the name and the description can be shorter than 3 characters, then we can enforce it over here. And then once it's created, we know this value is always valid in whatever valid means inside our system. Okay, so back in the controller, let's map the request to this breakfast object. So let's say over here, breakfast equals, and here let's say yes, this seems about right. Let's make sure that we have here everything that we need. Right, so we take all the values and we generate a new ID. And for the last modified, we simply pass UTC now. Okay, the next thing we want to do is somehow, yes, save it to the database. Then we want to take the breakfast that we created and map it to our breakfast response. And from here, we want to return our response. Okay, now this over here will return 200 OK, right? Because we're using the base method OK. But what we actually want to return is 201 created. So let's go ahead and use the created act. And as you can see, there are a few options over here. We're going to use this one over here, but there are other options. Okay, now this method receives 3 things. First of all, it receives the action in which the client can retrieve the resource. So in our case, it's the get breakfast endpoint. Then because the get breakfast endpoint has a parameter called ID, then we need to pass over here an object that has the ID property. So something like this. Yes. And lastly, the response content. Let's just add the argument names so it's a bit more readable. Okay, so what we have at the moment is very common to see in controllers. The first step is mapping the data that we get in the request to the language that our application speaks. The last step is taking the data from our system and converting it back to the API definition and returning the appropriate response. And over here, we have the actual logic of our application, which we're going to implement now. Okay, so let me just remove these redundant parentheses over here. And back in our Boober Breakfast folder, let's create a new folder. It's called Services. And over here, let's create another folder called Breakfasts. And over here, let's create the iBreakfast service. And what we'll have over here is a public interface. Yes, iBreakfast service. let's leave only the create. And again, we only want to work with our internal models. So over here, we want our breakfast model. And the response, let's have this void for now. And let's change the name of this to breakfast. Great, now back in our controller, let's use this interface. So private, read-only, yes. Let's include the namespace and inject this to the constructor. Okay, if you aren't familiar with dependency injection, then we'll look into it in a few minutes. Now down here, let's use it to actually create our breakfast. So breakfast service, create breakfast, and let's pass it the breakfast. Okay, now let's go ahead and implement this breakfast service. Let's create here a new file. Let's call it breakfast service. And over here, let's have our public class breakfast service, the iBreakfast service interface. Let's go ahead and implement the interface. Okay, now as part of this video, all we'll do is just store it in memory. But over here, what you would actually do is use some repository or entity framework core to store it in the database. Okay, so what we'll have over here is private read-only dictionary, where we'll map an ID to a breakfast. Let's just initialize it. Then over here, all we need to do is breakfast.add, and the ID of the breakfast is the key, and the value is the actual breakfast. Great, let's just add a new line over here. And back in our controller, for us to be able to test this end-to-end and see that this actually works. So in the get breakfast, let's try to retrieve the breakfast with a given ID. So yes, something like this. Let's generate this method. Right, so this generated the get breakfast method, which we'll implement over here. So implement interface, and all we need to do is simply return the breakfast that corresponds to the ID that we just received. Okay, now that we have this method implemented back in our controller, let's map our breakfast to the breakfast response. So yes, and let's return the response from here. Okay, let's run the project and make the create breakfast request and see what happens. Okay, now some of you might have expected this failure. So the failure we're getting is that the framework doesn't know what to do when someone requests the iBreakfast service interface, right? So back in the controller, we're trying to use the iBreakfast service interface. Okay, now what actually happens behind the scenes is that every time we send a request to the service, the framework creates a new breakfast controller object. When it creates the new breakfast controller object, it also tries to create a new iBreakfast service object. And the framework doesn't know how to instantiate the interface that the breakfast controller is requesting. So to fix that, let's go to the program CS and over here, define how to create the iBreakfast service interface. So builder.services.add singleton, the yes breakfast service. Okay, and what we're telling the framework is that every time it instantiates an object, and that object requests the iBreakfast service in the constructor, then use the breakfast service object as the implementation of this interface. And over here, we have a few options for the lifetime of this breakfast service object. So specifying here singleton tells the framework the first time that someone requests the iBreakfast service interface, then create a new breakfast service object. But from now on, throughout the lifetime of the application, every time someone requests this interface, always use the same breakfast service object that you just created. Another option over here is to say scoped. Scope says within the lifetime of a single request, the first time someone requests this interface, then create a new object. But from now until we finish processing this request, every time we create an object and it requests this interface, then return the same breakfast service object that you created before. Okay, there's also transient, which as you would expect basically says every time someone requests this interface, create a new breakfast service object. Okay, now looking at our breakfast service object. So because we're persisting our breakfasts inside this dictionary over here, we don't want this dictionary to be recreated every request. So let's change this to static. Okay, and over here, let's change this back to scoped. Great, let's try running our application again and see if it works now. So we make the create breakfast request. As we can see, we get here the HTTP status code 201 created. We get the location header, and we get the breakfast response, which contains the server generated ID and last modified daytime. Great, let's take the ID of the breakfast that was just generated and let's try retrieving it over here. So let's replace this ID with the ID of the breakfast and make the GET request. And we can see that this works as we expect. So we get HTTP status code 200 OK. And over here again, we have our breakfast response. Okay, now one thing about the create breakfast. So let's create another breakfast. We said that the location header contains a route which we can use to retrieve the resource that we just created. So let's try and using this to retrieve the breakfast. So I'm copying it and pasting it back over here. Now, if you want to send multiple requests from the same file, then you can do it by typing 3 hashtags. And you can see that now we can send another request from the same file. Let's use HTTP GET and make the request. And we can see that it works. Back in our controller, let's implement the methods that are still missing. Let's also stop our service. So let's implement the update endpoint. So over here, let's create a breakfast given the details that we have. Great, so it's similar to the create, only that we're using the ID that we got from the route. Then we want to use the breakfast service to observe the breakfast. So yes, let's generate this method. And we want to return here no content. Now, if you remember, then in this endpoint, we want to return no content only if the ID is an ID of a breakfast that exists in our database. Otherwise, if this is a brand new ID and the details here are valid, then we want to create a new dinner and we want to return here a similar response as we're doing in the create endpoint. So let's add here a to do, return 201 if a new breakfast was created, right? Last but not least, let's delete the breakfast. So breakfast service dot delete breakfast, and let's pass it the ID. Let's generate this method and return here no content. And back in our services, let's implement the 2 missing methods. So implement interface. Delete will be simply remove the entry with a given ID. And for upsert, they'll simply be breakfasts and add it to the dictionary. Okay, let's make sure that this works as we expect. So let's rerun the service. So created a new breakfast. Let's copy the ID and paste it over here in the get breakfast. Let's try retrieving it, and we retrieved it successfully. Let's copy the ID to the upsert breakfast, and over here, let's change this. Let's make it, I don't know, vegan sunshine 2. Let's make the request. We can see we got here no content, which means it was updated successfully. Let's try retrieving the breakfast again. And we can see we got it with the updated value. Now let's copy the ID and delete the breakfast. And we get no content again, which means that it deleted it successfully. So now if we try to get the breakfast again, what do you think will happen? And an exception was thrown. And we can see over here the exception that occurred. So this is basically the exception to string. Here's the exception message. And here's our stack trace. Okay, and if we go back to the breakfast service implementation, okay, we can see that this happens because we're not accessing the dictionary safely. But before we fix this, we actually never want to return to the client the exceptions that were thrown. It may contain sensitive information, and also we don't want the client to see the stack trace and what happened inside our system and how it's implemented. So let's add global error handling, which basically means how we handle exceptions that are thrown in our system. So back in the program CS, we're going to add a middleware as following. So use exception handler, and over here, let's specify some route. So when I said that you can imagine that the request simply arrives to the controller, so basically what we have is a pipeline that our request goes through. And if you aren't familiar with middleware, then you can imagine it like a sandwich of code. You can write code that runs before and after the next piece of middleware, where somewhere down the road, one of the middlewares actually invokes the controller. What we did over here is we're using a built-in capability of the framework to add code that basically adds a try-catch surrounding the following middlewares. And then if an exception is thrown, then it catches that exception. It changes the request route to the route that we defined over here, and it re-executes the request. And what this means is that over here, we can create a new controller, and we can call it errors controller. So public class errors controller. Yes. Let's just change this to controller base. Let's say that the route here is error, and let's change this to problem. And let's explain what we have over here. So like we said, it re-executes the request to the error route. Then over here, we can have whatever error handling logic that we want. Currently, all we're doing is using the problem method from the controller base, which will return the HTTP status code 500 internal server error. So I want us to run the program and see what this looks like now. So let's rerun it and make the GET request again. So we don't have anything in the database. So this should throw an exception. And we can see that we no longer get the exception as it was thrown, but we get this nice response with 500 internal server error, and no sensitive information will return to our client. Okay, so this brings us to the next part of our video, which is error handling. So there are many approaches for handling the error flow in our system. What we're going to do today is use an approach from functional programming, where basically what we'll do, we'll say when you request a breakfast, we'll either return the breakfast like you requested, but if for some reason we can't do it, for example, the breakfast doesn't exist, then we'll return an error that represents what happened. Okay, so let's see what this looks like. So first of all, I want to add a new package to our application. So .NET add to the Boober breakfast project. A package, okay, now this package is called error. It's my personal favorite for handling this approach. Okay, now if you know me and you know this package, then you know I'm not very objective. And that's because, well, I wrote this package, but it really gives you some functionality that doesn't exist in other packages. So let's get familiar with it. I actually made a video about the two main approaches for flow control. So if you're curious to see exceptions for flow control against this kind of approach, then make sure to check it out. We look at multiple open source libraries and you can see what's right for your application. Okay, so inside the Boo breakfast folder, let's create a new folder. It's called service errors. And over here, let's create a new file. Let's call it errors.breakfast.cs. And what we'll have over here is a public static class errors. And inside here, a public static class breakfast. And in here, we'll define all the errors that we expect to have in our system that are related to the breakfast resource. Now over here, an error that we're expecting to have is a breakfast that doesn't exist. So let's go ahead and represent that error. So public static error not found. Now if we look at this error object, then we can see it comes from the error package. And what this is, so it's a simple struct which has inside three things. It has a code, which is unique to the error that occurred. It has a description, which is a human readable description of what happened. And it has an error type. What is this error type? It's a simple enum, which has inside failure, which is the default value, and some other errors, which are common in any system, right? So in our case, we have something that wasn't found. So let's go ahead and use this one. So the way this works, you can do error dot, and over here, you can use each one of these methods to create the corresponding error object. Plus, you can also use some custom integer value if you prefer. So in our case, we want not found. And what you give it over here is the unique code. So for example, breakfast dot not found, right? So this is the code. For the description, let's say, yeah, something like this. Then back in our breakfast service, this returns either an error or the breakfast. Okay, now this error or object comes from the error or namespace. Okay, let's update our implementation as well and see how we'll use it. So error or breakfast, let's include the namespace. And what we can simply do now, try to retrieve the breakfast. So try get value that corresponds to the ID inside this variable. If this succeeded, then simply return the breakfast. Otherwise, we want to return an error. In our case, yes, exactly this. Let's just include the namespace. And if you're asking yourself how these two become this error or object, then inside the error or object, you can see that we have two implicit converters. One that gets the value, in our case, the breakfast, and converts it to an error or object. And the other one gets an error and converts it to the error or object. Okay, so that's how it works behind the scenes. Then back in our controller, then when we're getting the breakfast, this no longer returns breakfast, but it returns an error or the breakfast. right? This is no longer a breakfast, but it's the get breakfast result. Okay, now this may contain the breakfast, but it also may contain the error. So over here, we want to branch out depending on what we have. So we can say if the get breakfast result is an error, and yes, similar to this, let's accept it and understand why this doesn't work. So back in the error or object, this actually contains either the value or a list of errors. So you're not limited to store only one error. So back over here, we can access it using the first error property. Then if the first error is not found, then we want to return not found. Otherwise, we know we have the breakfast in our hand. So we can say breakfast equals, yes, the get breakfast result dot value. So this will simply return the breakfast that we returned. We can map it to the response and return it same as we did before. So let's run this and make sure that it works. Okay, so we're making a get request. And since we don't have any object, then we get not found as we want. But if we first create it and we take the ID and use it to retrieve, then we see we get the response as we expect. Okay, so back in the breakfast controller, you may be looking at the method that we implemented, and you're thinking to yourself that this is much less readable than what we had before. After all, we can simply throw an exception from the breakfast service and catch it over here in the errors controller, and then our controller can stay like it was before. So you are right. Let's see how we can make this a bit more concise. First of all, let's extract this mapping logic to a method. So extract method, and let's give it the name map breakfast response. And I want us to get familiar with the following capability of the error or object. So for now, let me comment out all of these lines and see how we can use the match method. So what we're able to do is say return get breakfast result dot match. So as you can see, the match method receives two functions, one that will run if what we have is the value, in our case the breakfast, and another one that will run if what we have is an error. So let's see how we can use it. Let's define the first function. We have a breakfast. If we got the breakfast, then we simply want to map it using the method that we just defined. So map breakfast response and pass it the breakfast. And if we have an error, so this is the list of errors, what we can do is handle it over here. For now, let's just return here a problem and see how this behaves. So let's run the application again. And we try to make the get breakfast request. Then we can see that it correctly invoked the problem method. Okay, so I want us to go back to the breakfast controller. So currently we're checking if the first error is specifically one of the service errors, but actually what we can do is we can take the type of the error and according to the type, return the appropriate response to the client. So if you remember, back over here, the type of our error is not found. So we don't need to do something that's very specific for this error, but rather we can do something that's a bit more general. So for that, what we'll do, I'll delete all of the logic over here. And I want us to implement our own problem method. So for that, I'm going to go over here and create here a new controller, which will be the base controller of the other controllers. Let's call it API controller. So over here, we'll have a public class API controller, which, yes, will inherit from the controller base. And as we said, this will be the base controller for the other controllers. So let's go ahead and instead of inheriting from the controller base over here, instead, let's inherit from the API controller. And because these are attributes which we can expect on any one of our controllers, let's move them to our base controller. And over here, like we said, we'll have our own problem implementation, which will receive a list of errors and return the appropriate response. So the way this will look is protected action result problem, which will receive the list of errors. And for now, let's have here something simple. So let's say var first error equals the first error, yes. And over here, we can say that the status code depends on the type of the first error. So we can say type switch, and over here, yes, something like this. So we can say if it's not found, then status codes dot not found. If it's validation, then we want 400. Otherwise, let's return here internal server error. And we also have here conflict. So let's go ahead and use that as well. So conflict will be conflict, exactly. And over here, let's return a problem where the status code is the status code and the title is the description of the first error, right? As so, let me just close the terminal. Okay, so all we have at the moment is our own base controller implementation, which the other controllers will inherit from. And what we'll do from now on is in the controllers, when we end up with a list of errors, then we'll call our own problem method, which currently all we're doing is taking the first error, using the type to compute the correct status code, and then we're using the problem method from the controller base to return the status code and the description of the first error. Okay, so now that we have this defined back in the getBreakfast method, then what we can do over here is pass the list of errors to the problem method. So now this problem method is the one that we implemented in our base controller. And that's it. Let's make sure that this works. So stop the program, run it again. And now when we try to retrieve breakfast that doesn't exist, then we can see we get here the description of the first error, and we successfully converted the error type to the correct HTTP status code. Great, so back in the controller, again, all we're doing is calling the breakfast service, receiving an error or the breakfast. If it's the breakfast, then we're mapping it to the correct response and returning it to the client. Otherwise, we're using here our custom problem method, which converts the list of errors to the appropriate response. Great, let's go ahead and do the same for the rest of the methods in the breakfast service. All right, so this will be error or created. This created also comes from the error or library. For the upsert, let's say error or updated. And for the delete, let's say error or deleted. Then back in the implementation, let's update this. So this is error or created. This simply returns result.created. Again, this comes from the error or library. In the delete, then it's error or deleted. And let's copy this, paste it in the delete method and change this to deleted. And lastly, we have the upsert. So we have this error or updated. And we can return here result.updated. Okay, now one of the reasons that I really like this approach is because as the application grows and we have more and more errors, then all the errors are neatly organized over here. And over here in each method, it's very clear to see what happens in the good flow and what happens in the bad flow. Okay, let's update the controller as well. So over here, we get the create breakfast result, which is error or created. First of all, we can get rid of this entire thing. Instead, use the map method that we created, right? So this will be breakfast. And then for now, we can say if create breakfast result is error, then we want to return problem and pass the errors to the base controller. Otherwise, we want to return the same response. And then let's just move this to the bottom so it's more organized. Then let's start with the delete. So this returns the delete result, which is error or deleted. Then over here we can say yes, actually, right? So if it deleted, then we want to return no content. Otherwise, if there's an error, then we want to return the appropriate response. And lastly, the upsert. So over here, if you remember, we want to return 201 if a new breakfast was created. Okay, so it would be nice if the upsert breakfast method could somehow tell us if it created a new breakfast or not. So to do this, what we can do actually is go over here and instead of returning error or updated, which comes from the error or package, we can create our own response model. Let's say something like upserted breakfast result. And this could be whatever we want. So for example, public record struct upserted breakfast. And here we can have whatever extra details that we want. So for example, is newly created, which will indicate if it created a new breakfast or not. And then over here we can say var is newly created equals yes, right? So if the breakfast dictionary doesn't contain the given ID, then we're creating a new one. Then what we still have left to do is update the method definition. So this will be upstarted breakfast, both here and here. Then we can return here a new upstarted breakfast and pass it the is newly created value. Then back in the controller, this returns the upstarted result. And over here, we want to return 201 if a new breakfast was created. So because we have the same thing over here, let's extract this to a method. Let's call it something like created at getBreakfast. Let's fix the indentation and move it to the bottom. Okay, back in the upstart method, what we can do now is basically upstarted result dot match. Yes, almost. So if it upstarted, then what we want to do is check if it was newly created. If yes, we want to return created at, let's fix the typo, get breakfast. Otherwise, we want to return no content. Lastly, let's just align the variable names. So this is upstart breakfast result, and over here, it's delete breakfast result. Great, so that seems about right. We can actually make the create breakfast a bit more concise. So we can replace this entire thing with create breakfast result, and we can match on the result and say if it was created, then we can return the created at get breakfast and pass it the breakfast. Otherwise, we can use the problem method and pass it the errors. Okay, so just to recap, all the errors that we expect in our system sit over here, and we have them well defined with a unique error code and a descriptive description. Then in our iBreakfast service, then we define for each one of the methods that they can either return the expected result or an error. Now, because we aren't really expecting any error in some of these methods, then we could have simply replaced it with void. But I just wanted to demonstrate another capability that might be relevant in your application. Then lastly, in our controller, then we get the response and we return the appropriate response to the client based on whatever result we received. Great, let's run the project and make sure that everything still works as we expect. So we create a new dinner. We get here the response that we expect. Let's take the ID and use it to retrieve it. Great, this also works as we expect. Let's try updating it. So we get no content, which is good. It means a new resource wasn't created. Let's try deleting the breakfast, and we get no content again, which means that it was deleted successfully. So now when we try to get it again, then we get 404 not found. And if we do upsert, then because it doesn't exist, we expect it to create a new dinner. So let's try, and we see we didn't get no content, but rather we got 201 created with a new resource and the given ID that we specified. Great, let's make sure that this was stored in the database. So let's try to retrieve it, and we can see that it was stored in our in-memory database as we expect. Now let's move on to the final part of this video, which is enforcing our business rules on our internal service models. So if you remember over here, when we create the breakfast, then there are some rules that we might want to enforce on the data that we're receiving. So at the moment, the client can call us with whatever information that he wants, and we'll simply store it. And also the controller can put whatever value that he wants over here in the last modified datetime, and we'll simply store it as is. It would be nice if we can simply take the data and say, okay, here's a breakfast if everything was valid and it adheres to the rules that the business defines. Otherwise, here's a list of well-defined errors. Okay, so let's see how we can do that. So over here, let's create a static factory method, and this will look as following. So public static, this will return an error or a breakfast. And let's call this create. Let's just include the error or namespace. Okay, and the way this will work is that we'll change the constructor to private. So we're the only ones that can call it. Over here, we'll receive the various details. So Yes, this seems right. Let's just inline this. And now instead of enforcing our logic over here, we can go ahead and enforce it over here. So the way this could look, so let's say, for example, the name needs to be between 3 and 50 characters, and the description needs to be between 50 and 150 characters. Okay, now I'm giving this as an example, but something you might actually want to do is make sure that the start and end time are actually values that make sense for a breakfast, and that the start date time is in the future. Okay, so let's look at how something like this can be implemented. So for example, public const int min name length. Now let's have it 3. And let's have the max name length. We said 50. And let's have the same thing for the description. So let's change name to description. Let's change 3 to 50 and the maximum to 150. Then over here in the create method, then we can say, okay, if the length of the name is less than the minimum length or greater than the maximum length, then over here we can return an error that represents that the name is invalid. So for example, let me just close everything so it's more organized. We can go to our service errors to the breakfast and create here some validation error. Let's call it invalid name dot invalid name. And over here we can say that the breakfast name must be at least yes, this seems right. Let's just update this to models.breakfast.min name length, both over here and over here. And let's wrap the line. Great, then over here we can simply return errors.breakfast.invalid name. And we can have similar logic for the description. So let's change name to description. And here as well. And let's add the appropriate error over here. And here let's change everything to description as well. And this should be also description. And now this should work. Great. Now we can actually make this a bit better. If you remember, we said that internally we have here a list of errors. So we don't actually have to return only one of these errors. We can actually return all of them. So what we can do, we can create here a list of errors. And over here, simply add it like so. And same thing over here. So errors.add and add the appropriate error. And in the end, we can say yes if there are any errors. Then let's simply return the list of errors. Okay, so similar to the other implicit converters, there's also an implicit converter that takes a list of errors and returns an error or object. Okay, back in the controller, breakfast.create, and we no longer need to pass it this and this since it's generated inside. We can call this request to breakfast result, which is either the error or a breakfast. Then we can say if this thing is an error, then we want to return a problem. Otherwise, we know we have a breakfast in our hand, and we can simply extract the breakfast from the error or object and use it like we did before. Okay, same thing over here in the upsert. So here we would have breakfast.create. We would remove this, but we do want the option to pass the ID. So let's create here an optional field with ID. And back over here, let's just move the ID to the end. And same over here. So this will be request to breakfast result. And over here, we can say if it's an error, then return the errors. Otherwise, let's take the breakfast and we continue like we did before. Then over here in the create method, let's generate a new ID, only if an ID wasn't specified. And that's it for now. So just to recap what we have, we changed the constructor to be private, so no one can create a breakfast other than using the create static factory method. Then over here, we can enforce whatever business rules that we have that have to do with the breakfast object. Okay, so we're encapsulating logic that has to do with the breakfast inside the breakfast object. Finally, we're returning either the breakfast or a list of errors to the controller, which it's the controller's responsibility to make sure that what he has is a valid value. Now back over here, we would simply return the first error, and that's a shame because we know we have here a list of errors with details that are very relevant to the client to know how to fix his request. So instead, let's check if everything that we have in this list of errors are validation errors. So we can say if errors dot all, and the type of all of them is validation. Then what we want to do is return a validation problem. So the controller base has another method which is called validation problem, which if we give it a model state dictionary, will convert it to a beautiful error response which contains all the details. So let's see what this looks like. So we want to create here a model state dictionary. And to this model state dictionary, we want to add all the errors that occurred. So the way we can do this is, yes, exactly, right? So we're simply iterating through the errors and adding a dictionary entry with the error code and the description. And then we need to pass it to the validation problem method as so. And that's it, right? So we're basically saying if all we have are validation problems, then let's return bad request with all the details. And this will return a standard response. Otherwise, let's take the first error and return the appropriate response. You know, we can actually make it a bit better. So let's imagine that 5 errors occurred. If even one of them is an unexpected error, then we can't really trust any of the other errors. So we can add some logic that says if there's any error where the error type is unexpected, then we want to return 500 internal server error. Okay, let's run our project and make sure that it behaves as we expect. Let's first look at the good flow. So creating a new breakfast works as we expect. Let's try retrieving it. Works as we expect as well. Let's try updating something. We get no content. So let's try retrieving it again. We can see that we got the updated value. Lastly, let's try deleting it and we get no content. So when we try getting it now, then great, we get not found. If we try to upsert it, then we can see it was created as we expect. Now I want us to test the error flow. So let's put here some details that are invalid and try to make the request. And we can see we got bad request with descriptive errors of what happened. Let's just fix the space that we're missing. So back in the errors, let's add a space both here and here. You know, back in our breakfast controller, we can actually add another static factory method, which knows how to take the request and return the same result. So let's see what something like this would look like. So back in the breakfast object, similar to the create, we can have here a public static error or breakfast, which receives the create breakfast request and simply calls the create method like we did in the controller. And we can do the same thing in the upsert method as well. So over here, let's do from. Let's replace this entire thing with the ID and the request. And let's add here another static factory method, which knows how to take the ID and the upsert breakfast request. And similarly, you'll call it with the details and the ID, and we'll return an error or the breakfast. Great, we can remove this comment. Okay, now if you're looking at this over here and you're thinking this is much less readable than what we had in the beginning, and if we simply threw exceptions both for the breakfast object and for the breakfast service, then you are right, we are paying here a price of readability. But I want you to remember that as the application grows, over here we currently have one controller and one service, but as the application grows, we'll probably end up having many services, many controllers, and more logic down the road, and throwing exceptions makes it hard to understand what the error flows in your application are and what errors can occur. So personally, even though this approach can take a few minutes to get used to, what you gain is that you have your errors well defined, and as you're developing the application, you're mindful of the scenarios that might occur. Okay, so that's it for this video. I really hope you had a good time and you have a better understanding of how to build a CRUD-based REST API completely from scratch. I cover topics that are a bit more advanced in my channel, so if this was intriguing and you enjoyed it, make sure to check it out, and I'll see you in the next one.